Projectiles. So in 2000 here we have a horizontal landing question. Where we have particles projected with a velocity of u meters per second at an angle beta to the horizontal ground. And we have to show that the particle hits the ground at a distance of u squared over g times sine 2 beta from the point of projection. And we have to find the angle of projection, which gives a maximum range. So if we do a little sketch, we have our initial velocity is going to be u meters per second. The angle with respect to the horizontal is beta. And then we have to show that when it hits the ground, that the range is given by u squared over g times sine 2 beta. Now we know on landing that sy will equal 0. And if we start by filling out our table, then we will be able to use this sy equals 0 to work out what our range is. So we know that in general that our initial velocity u is given by u cos alpha in the I direction plus u sine alpha in the j direction. So if I fill out my table, u in the x direction is u cos beta. U in the y direction is going to be u sine beta, because our angle in this case is not alpha, it is beta. A in the x direction is 0, a in the y direction is minus g, therefore vx in the x direction is u plus at, so in other words u cos beta, and v in the y direction is u sine beta minus gt. S is ut plus a half at squared, so in the x direction that's u cos beta t, and s in the y direction then is u sine beta t minus a half gt squared. So we need to find when is our object landing, in other words, what is our time of flight. So we say that our sy is equal to 0 on landing, so our sy is u sine beta t minus a half gt squared. So by letting that equal to 0, I'm going to multiply across by 2. And then I'm going to factor out t as being common, which leaves me with 2u sine beta minus gt. So by letting t is equal to 0, or 2u sine beta minus gt equals 0, then I can see that my time must be 0 at the start, because it hasn't left the ground, and then t must equal 2u sine beta divided by g on landing. In other words, this is our time of flight. So now I can say, well, s of x is equal to my range at the time of flight. And I know that s of x is equal to u cos beta t. So that means if I put in for my time of flight, I have 2u sine beta over g. And of course, u by u is u squared. So I have u squared times 2 cos beta sine beta. And of course, if we go to, let's say that's over g. If we go to our maths tables, page 14 then, what we can see then is we have 2 sine a is equal to 2 sine a cos a. So we have a 2, we have a sine beta, and we have a cos beta. So therefore I can write sine 2 beta is equal to 2 sine beta cos beta, which we have. So therefore that can then be written as u squared sine 2 beta over g. And that's what they wanted us to show. So we say QED. And then the second part says, well, find the angle of projection which gives a maximum range. So here's my range. So the maximum range occurs for the maximum value of sine 2 beta. But if we remember from trigonometry, the greatest value that sine 2 beta can have, if we sketch our graph, is 1 and minus 1. So therefore, if the greatest value that sine 2 beta can have is 1, then 2 beta must equal sine inverse of 1, which is, of course, 90 degrees. And therefore, the greatest value that we can have for beta is 45 degrees. In other words, 45 degrees gives us the maximum range. Okay. So this is quite similar to the example 3.4 in your textbooks on page 42. And in that example, it's nice to actually go and have a look at, because it also asks you to show that the greatest height is reached when we have u squared sine squared alpha over 2g. So do try that as well.